All right, Jennifer, thank you. Welcome back to Studio B. Time now for our second installment of our Wise Guy segment. Mats Selen, U of I physics professor, rejoins us, continuing our discussion on magnets.
Right. So the Earth's magnetic... I drew a little... This is the total extent of my artism now. So this is better than it was. So this is the Earth here.
Okay.
And these red lines represent the magnetic field lines of the Earth.
Okay.
Which is to say that if you were to sit out here in space with a little compass, that's the direction that the needle would point. Okay.
Right.
And so that's what we also see on Earth. Now, it's very interesting because if you look at the geological records, you can study the strength and the direction of the magnetic field because it gets frozen into rocks. Basically, rocks record this information, and you find that the magnetic field of the Earth has switched directions hundreds of times. I mean,
really?
many times, yeah. It's sort of on average every 250,000 years or so, it changes. It hasn't changed for the last 750,000 years, so maybe we're overdue, maybe we're not. I mean, there's some very big fluctuations, but it's actually a very interesting thing. And some other stuff that I learned when I was reading about this yesterday was that in a recent study, you know, with satellite photographs now are pretty decent resolution, so people looked at grazing cattle, okay, all over the world in different pastures, and they discovered that cows tended, when they were grazing, to line their bodies up along the direction of north to south.
Interesting.
Which is so very strange. I don't even know if this is correct. I mean, I only read the abstract, but it was a scientific paper in a medical journal, so maybe it was. And they also discovered that if you looked at the cows that were close to power lines, you know, where you have other field emissions, then they sort of lost that ability. Well, you know, I don't think the cows really care, but you know, that was sort of interesting.
So is that how the cows come home?
Yes, that's right. So the cows follow. They have little magnets. So, anyways. So the big question is, how does the Earth make this magnetic field? Because if you want to make a bar magnet, you can't have. If you take a bar magnet and you heat it up so that it's the same temperature as the center of the Earth, it would just it wouldn't be a magnet anymore.
Right.
So you'd have above the Curie temperature. And so there must be something else going on. And you can get a magnetic field by having electric currents.
Okay.
Okay. And so the belief is that there are charges that are moving that have to do with the rotation of the Earth somehow inside. In the molten iron, or you know, the molten metals that are in the center of the core of the Earth, kind of they convect around, and that motion generates this magnetic field of the Earth. So I want to illustrate that a little bit with this thing. So what I show you first, if I plug this thing in here, I have a little gadget that I built to measure magnetic fields. So here we go. And so if we just turn this thing around so you can see the screen.
Got it.
Okay, what you're seeing here is that you have three lines. That is the X, Y, and Z components of the magnetic field that's right here in this room.
Sure.
As relative to this thing. And if I put it inside here, and if I just hold it, and then I just turn on this power supply, and then I increase the current a little bit. Can we see that screen?
Yeah, it's
okay.
The red dropped off, and that's spiking.
Yeah, so you can see the thing changing, and the red measures the field along this direction. That's the X direction with this thing.
Okay, sure.
So what I'm doing as I'm changing the current this thing is I'm making the magnetic field that goes sort of through the axis of these two loops. Okay?
Got it.
And so somehow what that means is that if you can make a current that kind of goes around and around and around, then you can have a magnetic field that goes sort of through that concentrically in a sort of a way. So in other words, the Earth would have a magnetic field sort of like if you had some currents that were, in a sense, kind of going around the Earth, around the rotation axis of the Earth, or at least in that general sense. They probably have to go around in little pockets. I'm not an expert geophysicist, obviously, but if you had moving charges inside the Earth, you could generate the magnetic field the way it is, and that's called the Dynamo Effect. And if people are interested in this stuff, there's actually an excellent Wikipedia article on this. If you just go Earth's magnetic field and you type it in, and you can learn all this neat stuff about the Earth's magnetic field.
Well, cool. Well, thanks for learning us, I guess you could say, today on magnets.
Well, certainly.
All right, Matt. If you want to see a replay of this, get this information once again, go to our website, omahomepage.net. Look under the morning show and look under Wise Guy. We'll have